Awesome. So, I just want to quickly share the HDA and how it works. If you don't know what exactly the HDA does, you can visit my site, my blog post about it, where I talk about basically how to make your particle simulations look more fluid-like. And yeah, and so this is the hip file that I use to create the content for my blog post. Although I did change a few things, and this is the starburst now. It looks a lot more interesting. It looks a lot more fluid-like. It looks really, really cool. Um, so yeah, it's using the new HDA that I made for it. It's gonna be fully unlockable. You can dive it right in and go through how I made the whole thing. Annotated some stuff. Oh gosh, forgot to bypass that. Yeah, I annotated a few things as well, so you guys can see how it's all built. Save node. Awesome. Um, so let's have a look at exactly how this works. Um, you can see how flexible and how how much variations we can get out of this node. Um, a lot of these parameters are just a good quality of life improvements instead of like creating it yourself all the time. And yeah, so let's go over my emitter first. Let's clear the viewport. So my emitter is just a sphere. Scatter a bunch of points, getting the normals. Um, and this wrangle is just to initialize our velocities. So you can see this velocity vector that I have right now is just a vector that flows across the curvature of our sphere. Um, and then have some rest, probably for shading, I don't know. And this one is just to remove the points and create a bit more of an organic kind of emitter, so it looks nice and flowy. Okay, so what does it look like without the HDA? Obviously, it's gonna look really crazy. It's not what we want. Um, in fact, let's just start over. So pop non-divergent. That's the one. So the few things that we want to do first is figuring out the rasterization settings for our particle sim. Um, the voxel size is gonna be very, very important of how the look will end up looking like. So with the default settings, we're getting this crazy look. So all these are just are artifacts. Boom, boom, all these explosion, and that's because it's coming from our gradient force. It's completely uncontrollable right now, and it's not because it's our divergence. This gradient force doesn't actually have it's actually not divergence free. So if I just stick that on, we don't have that effect anymore where it's just popping out crazy. So yeah, but I just left it off because I thought it would create some interesting look. Anyway, so yeah, as I've said, rasterization settings. You kind of want to keep it to if you just run the thing a few frames, go inside the subsolver, and inside this After we rasterize the particles, we should see our volumes. If you middle mouse click, our density is currently 400k voxels. That's kind of low res, and so we kind of want to have it hovering around 800 to like a million. But yeah, I'm just gonna go low. I'm just gonna set it to the resolution where I had before, 0.02, and this was to 1. And with this resolution, I'm gonna turn off the gradient first. Oops, go back. One chill. Another 0. A few frames. If I go here, so that's around 80k. Keep running. Yeah, so it looks like it's around 400k now. Maybe let's try 4. And keep this at 1.5. Yeah, maybe this is good enough. Yeah. Cool. So the next thing, once we're done figuring out the settings that we want, by the way, it is actually good to keep it at around medium resolution to low res, because we kind of want our velocity vectors to be averaged out and all these particles to be averaged out, and that's basically what makes it look a little bit more like fluid, is when things are kind of all the velocity vectors are blurred out. So yeah, next one is a velocity blend. That's basically just blending towards our final velocity vectors, which is the sum of the velocity, divergence-free velocity, and our gradient force. Threshold is just a limitation if the final velocity, if the speed of the final velocity is less than this threshold, then we won't update it to this final velocity. So basically what that means is we're keeping our original velocity and no update happens if the final velocity isn't fast enough, I say. Cool. So yeah, so under the vector fields or velocity, we have a bunch of controls. They look very similar because they are actually all the same. We can add some constant velocity, so we just add some value here. We can add a bit more like up force there, and we can add some curl noise as well. Let's see. Cool. We're adding some nice breakups already. Some kind of like disturbance or turbulence. Yeah, and regarding that crazy gradient, and I did say that if we do a project non-divergent on it, we get a more controlled look. Although that fixes it, we're losing that nice compression of our clumpiness of our particles, because that's what basically divergence free does. So instead, what I do is do some controls on our using vex. So with the use vex expression, we have a drop down here, we have a pass through, and these are the parameters that we can adjust. Bias is the velocity blend. Div free v is the velocity vector. Gradient dense is our gradient force. And I have this preset here called limit gradient force by density. And this is the one that kind of controls that. So if I remove that, we have this really lots of artifacts, right? That explosive, I don't know, just blobs here and there. But once I turn on that expression here, this gradient dense, we're removing. We've completely fixed it already. So what is this doing? So here I'm using the PT density, which is given to us by this HDA. Here PT density, and basically I only want the gradient density, the gradient force, to have more effect on particles that are more sparse, that have, so if I run the sim, that are these blue color. You know, if you go to visualize, you can see the range of our density. So basically what I'm saying is don't apply the gradient force on particles that are already very clumpy, but only apply the gradient force on the particles that are quite, you know, spread out. So that gives it the effect that it's trying to clump together to, you know, bigger masses of particles. So that's what I do, and that's basically what controls the gradient, the clumpiness, and all those artifacts thingamajig. So let's see if I increase all these values here. Now you can see we have nice stringy bits. We're getting this wild behavior already, but it still feels controlled, which is really good because of this expression here. Awesome. So now that looks pretty damn cool. Yeah, in terms of controls, we do have constant velocity here as well in our gradient. I'm not sure why that's the default. I should change that. We also have additional curl noise on it, and visualize is already there. The PT density will always be outputted. So we have PT density here. And yeah, I think that's pretty much it. The starburst effect is also out here, and the emitter is just a pyroburst source. It's this really quick emission, doing a bunch of modifications to the velocity, and inside in the pop net we have just this, the exact same settings. Nothing else special, adding some drag using the PT density as well as a mask, and force noise. That's basically it. So that's how it looks like. Cool. So yeah, I hope you guys make something cool out of this HDA, and if you have any questions, you can email me or message me, LinkedIn, whatever. Cool. Have fun.